Okay, so for problem number 9, we still are talking about round and wrinkled and yellow and green pea plants. And when we look at this time they give us the ratios of the offspring. For example, in this first cross, 3/4 round yellow and 1/4 wrinkled yellow. And they give us the phenotypes of the parents, but they want us to figure out the genotypes. Okay, so we're going to again approach this one trait at a time. I'm going to zoom in to the first cross for a minute here. And in this first cross, I'm going to try to get we have round yellow, and we get 3/4 round yellow, 1/4 wrinkled yellow offspring. Let's look at this one trait at a time. When do we ever see 3/4 round and 1/4 wrinkled coming out of two parents that are both round? We see that in this situation, big W, little w crossed with big W, little w. We will always see in that Punnett square three-fourths of the offspring will be round and 1/4 will be wrinkled. So we know one of the traits, or one of the genotypes, excuse me. But now let's look at yellow. With the yellow, we know both parents are yellow and all of the offspring are yellow. Interesting. So in this situation, there's two options. We see it when we have big G crossed with big G crossed with big G will give us big G offspring. All yellow. But something else will too. Big G crossed with big G will also give us all yellows because we'll get some that are big G and some that are big G. So in this case, your answer to part A, you can say, okay, we know one parent is going to be big W, big G. But the other parent could be big G or big G. That's what we can tell so far. Now let's look at the next cross. In this situation, we've still got these same traits. Wrinkled yellow, round yellow parents give this very interesting combination here. So again, I want you to look at this one trait at a time. All right? So when we're talking about let's look at wrinkled first. Really, there's two pieces of this that are wrinkled. So we're going to try to group those together. 6 out of 16 and 2 out of 16. That's really 8 out of 16 of these that are wrinkled. And if we say 6 out of 16 and 2 out of 16, that's really, again, 8 out of 16 that are round. And isn't that really the same as 1/2 and 1/2? So when do we see half of the offspring being wrinkled and half of the offspring being round? Well, we see that when the parents are big W, and little w, right? Because if we were to cross those two parents, we were going to say big W, little w, crossed with little w, what do you get? You get half of them that are round and half of them that are wrinkled. Okay, so we worked it out for the round and wrinkled trait. Now let's check out being yellow and green. Now again, when we ignore wrinkled and we just look at yellow and green, we want to say to ourselves, okay, the yellows are really 6 out of 16 plus 6 out of 16. That's 12 out of 16 that are yellow. Isn't that the same thing as 3 out of 4 of them are yellow? And if we just look at the greens, that's 2 out of 16 and 2 out of 16. That's 4 out of 16. When you add those together, that's the same thing as 1/4 would be green. When do we see this distinctive 3-to-1 ratio? When both parents are heterozygous. So that tells us that at least for the color, the yellow versus green trait, we're going to have a big G, little g from one parent and a big G, little g from the other parent. So for the B cross, this is what the parents would have to be in order to get these ratios.